So, yes, welcome to our July edition of the OWASP Vancouver Meetup series. This evening, we have two very special guests, Drew Dennison and Baljeet Malhotra. Drew is going to be our first speaker, and Drew is going to speak on detecting complex code patterns using Semantic Grep. Drew is the CTO and co-founder of R2C, a startup company that's working to profoundly improve software security and reliability to safeguard the human progress. Previously at Plantair, I think I said that correctly, he led the data-driven cyber insurance platform development and technical incident response on major data leaks for Fortune 100 companies. Sounds like quite an interesting and fun job, Drew. He received his degree in computer science from MIT and lives in San Francisco and spends his free time racing sailboats, camping, and trying to outsmart his two cats. And then, without further ado, I'll pass it over to you, Drew, and I'll give you presenter as well. And there you are.
Thanks so much. Let me just present here. That's quite an introduction, so I will try to live up to that. So as you mentioned, this is me. I'm one of the co-founders of R2C, and we're a small static analysis and cybersecurity company, a couple of friends, and we've grown out to 20 people. So the work I'm going to show tonight is primarily the work of many people. And generally, we try to open source as many of the tools we can because we think the security community needs better tools. Attackers only have to be right once, as we saw a couple days ago on Twitter. And as defenders, we can't make mistakes. So let's give a quick, I'm going to start out with just kind of giving you the summary of the talk. And so the first thing is that, I think the computers are really good at consistently applying human experience. And so, we have human intuition, but if we're going to kind of make sure we don't make any mistakes, we need more computer firepower to sit there and churn away on is consistently applying that. And then I think the future of security is more around paved roads. And so as we have more developers, with better frameworks, tools like libraries or ORMs make it harder to kind of make better classes of vulnerabilities. If you think back to when people were writing in C and C++, you have all kinds of memory corruption issues, and more modern languages, those have been removed. And so I think we'll continue to see that happening in security. Typically, I'm going to compare SemGrep to both grep and some additional static analysis tools and talk about how it combines some of the best of both worlds. Because just generally, I think these are good tools, but they often have downsides, as any tool does. And so just talk about some of the assumptions that we've made. And we need a tool that's fast, easy to use, multilingual, and of course, open source. Enter SemGrep. SemGrep aims to be lightweight, work across many different languages. So we have really good support for 5 languages. And then we have 2 more languages coming soon in alpha. So we have Ruby and OCaml and TypeScript this month. And then next month, we're going to do C++, or C#, probably Kotlin, Objective-C, and Swift. So starting to expand so more people can use the tool. Quick outline of the talk, so we'll just jump right in and I'll give you a demo, and then I'll step back and talk about kind of what's going on underneath the hood and alternative approaches and some of the trade-offs that we made. And then finally, we'll talk about how you can actually use the tool and how I've used it in the past. So tonight, I'm going to use an online editor. SemGrep is both a command line tool. We also have an online editor that is really similar to like regex 101 or things that I think is pretty nice to demo, and you can see the results right in your browser. So if you want to follow along, you can go to semgrep.live, but you can also use it completely offline, on your terminal if you do like brew install semgrep or pip install semgrep. All right, so the first thing as security engineers, this will be probably fairly obvious to a lot of people, but you have what we call like dangerous APIs. And so in like the node context, you have something like exec or eval, and Python has similar things, Ruby. Pretty much every language lets you call out and execute arbitrary code. And so in this case, it's totally fine. You're just calling exec looking for, all the files, but you can imagine maybe you're creating users. And so it's just usually a place where security issues creep in, and you probably want to go through and audit your code base. And so if you look at a pattern like this, you're probably thinking, all right, I could just write a quick grep rule. Maybe I'd audit my code base, by looking for exec left paren. We'll see it's very similar to that in SemGrep, but there's a couple powerful things that we'd have to consider if we wrote a pattern using grep. So here I have the live editor that I mentioned, and there's a little bit of stuff going on here, so I'll just kind of break it down. There's only three parts that are important to look at. So the first thing we have is the box where I'm going to type in the rule I'm actually looking for. And then below it, I have just a sample of code, so different test cases or cases I have to consider, and then matches will appear on the right. So we have exec ls, we have exec looking for a variable, and those would both kind of match the standard case, but then you might have some white space. Languages like Python, don't care about white space, so you have to think about that. You also might have something like safe exec, which is maybe a function that you've imported from a library. And so you wouldn't want to necessarily look at all those cases. And you might have multi-line functions because you've used a formatter or something like that. And then, of course, you have commented out code or just strings that all would typically match. And you have to think about if you're going to write code using grep. So what I'm going to do is I'm going to copy and paste this pattern into what I want to search for. But of course, I don't want to find just calls to ls exactly that. I want to look for calls with any arguments. And so I can use 3 dots as basically like a star in regex to just say, match 0 or more arguments, calls to exec, and I can go ahead and run that. So if I click run, pretty fast. And now you can see we have a couple cases. So we matched the cases we're looking for, and then the calls to like safe exec. What's going on underneath the hood is SemGrep is understanding that that's a different function. And so I don't actually want to flag that. And of course, it correctly ignores commented out code and strings. So that's one really quick dive just to give you a taste of the syntax. Let's talk about another case. So if you're familiar with Go, there's a unsafe package in Go that lets you kind of be as escape hatch. You can jump out of the type safety and some of the guarantees of the Go language, and you can do some pointer arithmetic. And so again, these are the kind of introducing some of the C type bugs, stir copy, mem copy issues where you have stack smashing and whatnot. And so generally, again, if you're gonna have a security problem, first thing I would typically do is like look to see if anyone's using one of these banned APIs. Cool. So here is a Go program. Loaded that up. It's got a couple little things. I'm doing some pointer arithmetic. And what I want to do is, again, do what we did last time. So in this case, I'm going to highlight some of the code. And I can actually right-click it. And let's see if that works. Never mind. I'll talk about that in a second. So I have calls to unsafe pointer. And we're going to use the 3 dots, just like we did in the previous example. And if I run that, I can see it matches the 2 cases. But I also want to find things that are all functions on the unsafe package, not just pointers. And so I'm going to replace this with a variable. And so in SemGrep, there's this concept where you can just put a $ and then all uppercase letters. And I can just say any function now with any arguments on the unsafe package. Let's see if we can find that. And so now it matches both pointer and size of. And so if I'm going to go through and audit my code base, I would then use a pattern like this with SemGrep, run it on the command line, look at all the instances, and kind of manually go through and triage the results and apply some human intuition. All right, so next we have a very common security topic, which is basically injection. I believe it's one of the most common OWASP categories. But in this case, what injection means is a user can control some part of the data that's flowing into your program. In this case, you're getting a file, so you have a call to a route. This is a Python web framework, but you're going to call get file with any file name, and then that's going to get passed down to this sensitive function where it's actually going to send a file down. And so if you're not careful here and you don't check to make sure that the file is allowed to be sent down, a user who's being clever can look for a file name where it's like .. / and read any file on your system. So of course there's mitigating controls you can do with defense in depth with limited permissions and whatnot. But generally this would be like definitely a code smell, something you want to talk to the developer and try to harden this up. So if we look at that, I'm going to load in again 2 test cases. So now this is Python code, and we have calls to basically an index file. That's safe, but what I want to look for is user data. So this file name argument is getting printed out and then passed directly to the send file function. And so I'd like to audit my code base for that. So again, I will copy and paste. And then I'm just going to go through this line by line and just use the two concepts we talked about at the beginning with the 3 dots to say, let's match any route, match any function. And then let's start using these variables inside our pattern. And so I'm going to do $FN for file name. And then I can use 3 dots to say, let's get rid of prints or log statements. Doesn't really matter. You can extract away one or more sort of statements in between it. And then anywhere in here, we need to just say flask.sendFile because SemGrep's going to go through and actually understand all of the different functions, what's their fully qualified name, so it doesn't have a false positive. If you have another function called say sendFile, it's a wrapper function. And then what I want to do here is I'm going to copy in $FN because that's the kind of the dangerous variable that the user controls, and we'll just use 3 dots again to say we don't care about any extra additional arguments. And great, we matched the case we care about, and we did not, correctly, we did not match all the calls to just send file here. So this is an example where SemGrep now under the hood is tracking where those variables are being defined and where they're being used, and you can incorporate that into the pattern, which you're going to search for. And so if you imagine trying to search for this using grep, you'd probably just search for all calls to send file, and then maybe you'd look for a couple lines around it, and you would have to really think hard about how you were going to construct your grep patterns to handle loggers, printers, being called inside functions, things like that. All right, let's talk about cookies. So if you've ever used cookie frameworks, I was surprised to learn that unfortunately a lot of the default arguments are not thinking about security. They're just trying to keep things simple. And so in this case, we have pretty standard Flask call. You're going to call response.setCookie, and then there's a key and a value. And so in this case, username Drew, and that's what you're going to find on Stack Overflow or the official documentation. But if you read closely on the API documentation, they'll give you a couple caveats like, okay, if you want to do this correctly, there's actually 3 cookie attributes we can set. And the first one is secure, and what that means is it will only send it over HTTPS connections. So if you're sitting at a Starbucks, reading your Facebook feed or whatever, you're not transmitting your Facebook session cookies over unencrypted traffic. The other thing you can do is you can tell the browser to sandbox the cookie and make it accessible only to the browser by setting HTTP only as true. And that means that JavaScript code can't just read it, send it off to some random server on an attacker system. And then finally, there's same site, which is a new attribute that basically restricts the cookie to only be on that same site. So again, I've done something here where I have a good case, and then I have some commented out code. And then I have 2 cases that we can consider here. So we have the sort of the hello world, just getting started, trying to use the library. If you're a developer, this is probably what you're going to write. And then we also have multi-line inner functions. And so again, if you're trying to think about how do I exactly write a regex to search for this, you have to, again, consider some of these different edge cases. And so now that I've shown you how you can write some simple patterns, let's talk about how we can expand this and make this more useful, because we don't want to just look and use it as a search function. We actually want to define a rule where we're going to encapsulate some knowledge that we as security engineers know and codify that. So the first thing I'll do is I'll give it a name. We'll call it Flask Secure Cookie. You can give it anything you want, but it's helpful to, when you have dozens of these rules running, it's helpful to have an ID. And then I've got just a little bit of logic here. So just like you have grep-v or something like that, you can do pattern not. And so we can filter out cases where it's good or secure. And the first thing I'm going to do is I'm going to say, okay, well, this is set cookie. How's that being imported? Well, it's being imported from Flask. There's a response object, but the developer, for kind of conciseness, has decided to use an import alias where they rename the response object as R, and then they call r.setCookie. So SemGrep doesn't care about the aliasing. It will go and map things down to the original object. So what we're going to do is look for all calls to flask.response.setCookie. And then I'll use ... because I don't care about the first couple arguments. And then we'll do HTTP only is true and secure is true. And I won't worry about same site because that's newer. We just want to look through our code base and we'll say, this is sort of the policy at my company. I want all cookies to have these two attributes, and in everything else, please let me know about it. And so I'll just do ... to say, match any other additional calls that don't have those two flags set. And then I could put a nice message here that says, please see cookies. And what we found works well is to usually put in a link to like the security Slack channel and let developers kind of reach out and say, hey, it'd be great if you guys could help me, or I'm writing some code. It'd be nice to get a second pair of eyes. But you can also put in more messages, and there's even a metadata flag. So if you want to put in like this is the OWASP issue or references to go learn more about how you can securely set cookies, that's all supported in this YAML syntax. But okay, so just to recap, we have something where we're going to filter out all the calls where it's done correctly, and then everywhere else I'd like to flag on that. And I have 4 different cases here. So I have an import and rename, I have multi-lines, I have commented out code, and I have the good case that I don't actually want to flag on. So if I run this, and hopefully by now you expect it to work, you can see we've matched the 2 cases that we care about, and we've correctly eliminated the false positives for the 2 other cases that we are not actually insecure. And so now I'd say this pattern is pretty much good to go. I'm going to go ahead and give it a name here. So I can just say secure cookie. I can save this. And then I get a nice little pop-up that tells me here's how I want to run this on my code base. So the first thing I'm going to do is just pip install semgrep. Once that's on my system, then I'm going to go ahead and run semgrep config, and I get a nice little zoomed in so they got a little scroll bar, but you can see I have a nice little config link, and we'll just download from this same URL here, semgrep.live, and then my pattern ID. And if I want to set that up in CI, I've got a couple different options here, so you can imagine how you start to enforce this. And then finally, we're going to look at another case. So if you imagine there's an API in your code base that's either being misused by developers or it's deprecated and you have a better one, how do we handle that in semgrep? So here we have a Go function. This is a built-in web server in the Go language, and just will serve things over whatever port you tell it to. But one interesting security consideration is, well, this is great for developers just trying to test things out locally. It doesn't support any of the SSL encryption, and so if you want to make sure that even all your internal servers are encrypted, you're probably going to want to use a different function, which is listen and serve TLS. And so if I jump in here, I have literally a hello world program, writes out hello world, a little function here, and what I want to do is just find all calls to this, and let's see if we can find that. And so what I've done here is I filled in a little bit more of a pattern, and so this says, okay, I have some metadata here with common weakness, it's an OWASP A3 issue, references, and a nice message here, and tells you please use this listen and serve thing. But of course, I want to help my developer friends out, and so let's see if we can provide an auto fix. And so the first thing I'll do is I'll just pull a few variables here. And so I happen to know with a little bit of research that this is the handler function. And then if I run that, it does match indeed, what we'd expect. But I also know that we can do a little bit better by providing an auto fix. And so what we have here is we have listen and serve TLS. And I can't quite make it like a completely automatic fix. If it was just like switch from API 1 to API 2, or like from YAML load to YAML safe load, I could definitely do it all without any human intervention. But in this case, the API is slightly separate because I need to have some SSL encryption details. So I need to have the cipher, and I also need to have the key file, if I'm remembering that correctly. And so what that does, obviously tells the SSL encryption, OpenSSL, how to actually perform the encryption. And so when I run this, now I get a nice little autofix suggestion, and I can hit apply fix. And of course, this code won't work because you're going to get two undefined variables. But now the developer can go through and start that out as a starting place, and then start to look up how they would read the key file in and start a conversation with the security team about how do you find that, how do you store it, is it referenced from another server, etc. But now I've started to encapsulate that. Hey, at our company, we don't want to use listen and serve TLS in production. We want to use listen and serve TLS. So all code that's going through my CI/CD pipeline, I'm going to provide this autofix. And in the live editor, you see here, you just paste the code in and hit fix apply. On the command line, you can also run with -- autofix. And then when it runs, it will print out and ask the developer, do you want to just overwrite the file? And so that works really well. And one of the core concepts that we've seen that works well if you want to have a security team and developers collaborate and start to evolve a code base rather than just finding bugs and being grumpy about them. Great, so you've seen a couple examples. We don't have time to talk through everything, and there's other kinds of logic with filtering. You can actually filter things with a regex. You can filter things with Python. I'll show one of those later. But if you want to get started and go through a tutorial, you can go to semgrep.live/learn, and there's an interactive tutorial you can play with. If anyone has any questions, I'm happy to take questions now. And if you didn't want to keep thinking about them, I'll take questions towards the end. But now we're going to dive into a tech talk. We'll talk about kind of how that all is possible and the magic that's going on underneath the hood.
Yeah, and if you have questions, you can either post them on the chat, in the Zoom chat, and I can moderate them. Drew, I don't see any outstanding questions at the moment. So yeah, let's type them, and then at the end we can allocate some time for responding to them.
Perfect. That sounds great. Okay, so if you think about the spectrum of different tools that are going on here, you have regexes and kind of grep, which is really easy, super fast. It works on every language. Almost every developer, security engineer has grep as part of their standard toolbox. And then you might have what's called whole program analysis, where you're doing data flow and you're looking at different types and you're resolving variables across multiple different projects. And typically that's done on build code, and you have to actually kind of build the project. And it can be very slow because you're having to do a lot of work looking across the entire code base. And so one happy medium is where you have these tree-based lints. And so if we talk about kind of what that looks like and how it combines the best of both worlds, diagram came from a great blog post by the Instagram security engineering team, where they talked about how they ran static analysis at scale on Instagram. And so you can look at the slides later. If there's a link there, don't worry about writing that down. But grep is great and regexes are awesome, but sometimes they're overused and they're not always the best fit for the job. And why is that? Well, it's because you have, I'd say, almost a fundamental mismatch. So even though we all write code as characters in Vim or our favorite code editor, to the computer, the first thing that's going to happen as part of a compilation step or as interpretation is it's going to parse the code into a structure that it understands. Every keyword, def or a decorator, and that means something to the compiler. And so if we can do our searching using that information, then we can be a lot more precise. And that's what we're going to try to do with SemGrep. So of course, this is not a new concept. If you've ever used a security tool like GoSec or DLint, Bandit, under the hood, that's what's going on. And you have, of course, linters like Flake8, ESLint, doing this for correctness checks, style checks. There's a lot of things you can do if you actually understand the programming structure. And so that's awesome. I've written a couple plugins for Flake8 in particular and ESLint. One thing is, though, you have to become an expert in sort of the AST syntax for every single tool you use. And ASTs are abstract syntax trees. It's kind of a term of the industry where you're just saying parse the computer into its symbolic representation, get rid of variable names, and operate things as a graph. And so that's cool, but you do have to understand kind of what's going on at a deep level in the programming language. You have to think about graph algorithms and what's the difference between a statement and an expression, which people definitely think about and have gotten a PhD on. and it's like the correct way to do it. If you're a security engineer, probably all you want to do is find all the cases in my code base where someone calls exec. I don't want to have to write a custom plugin for that. Of course, there's some commercial tools. There's a whole Gartner quadrant about this, but they often can be expensive. They're not open source. You can't customize them, and they can be fairly complicated to set up and configure. And so, like, even just I pulled the source code. If you've never seen one of these before, for ESLint, the like no eval rule, literally looking for calls to that dangerous function. It's like 300 lines of code because you have to kind of walk the whole tree, resolve, is it built in, is it in a rename? And so again, it's like pretty robust, but it's not as easy as just searching for the word eval. So if we go back to kind of this trade-off, where does SemGrep fit in? I think it fits in kind of neatly in the middle, where it understands the structure of what the code is running over and also the pattern you're writing, but we try to keep it as close as we can to the code you're trying to find is how you actually write it. And so that's why you saw me a couple times just copy and paste code and paste it into the editor and then go and replace a few things and abstract some things away. And then I have a fully built-in linting tool. So let's talk about in practice kind of how I've used this in my job and other consulting engagements. The first thing we think about, like how do you want to write rules? I always ask myself like these 8 questions because every code base, every security team, you have some institutional knowledge about where the bugs are in your code base. And so postmortems are a great way to look for rules that you could write. If your team is large enough and you've actually written some security frameworks, this is what I talked about earlier about like default frameworks, I think are the future, where you actually don't want to go through and try to understand, like, is everyone using that pointer correctly? You want to say, okay, like we know at our company, all front-end code is done in React. React has dangerously set in our HTML. So it's really easy to look for and tell the developer, like, you probably want to think twice before you do this. And everywhere else is safe. And so the developer can just focus on features. And as a security team, you can quickly audit it because people are using the default framework. And so some of my friends have written default auth frameworks, some encryption frameworks, and then they want to go through and ban all calls to like Bouncy Castle or the .NET crypto primitives, because they know that there's kind of a blessed way to do this, either for a good open source library or an internal library. And then when you look at code reviews, what are the changes you frequently ask for? A lot of those you probably express as a SemGrep pattern and start to automate that process, at least as a first line of starting the conversation. And then bug bounty submissions have been really fruitful in our experience. So if you look through, most bug bounty submissions, probably like 5% of those are related to code, or not just like, hey, an old version of this library, or like, oh, I don't like how you're doing this. But if you kind of filter through the ones that you actually do want to enforce in your code base, those are really powerful because it's something your security org cares about, you've actually paid out money for. And then if you kind of reach across to the engineering side and look at performance patterns, just general bad things, maybe someone's forgetting to log things and they're going to make it harder to do your incident response later. Can you help work with the security team by saying, hey, what if we like standardize on consistent logging frameworks? So that's been pretty fruitful. And then finally, things like infrastructure as code, misconfiguration is its own OWASP top 10 category, because so often that's easy to make a mistake there and have dramatic consequences. And so SemGrep can scan JSON patterns, and so it's pretty easy to write some basic logics using JSON to look through like AWS or Terraform files, things like that. And then lastly, if you think about sort of like deprecated APIs or invariants across your code base that you want to enforce, and you just say this should always be true, or like nobody should ever call the impersonate user function at Twitter. Let's go through the code base and get rid of that. Those are, again, great chances for autofix and letting computers do some of the work while you focus on more interesting problems. So that's generally what I think about when I write rules. And if we talk about like what a couple examples look like, so here's a fictional trading example application. And in one of the comments, sort of organizational knowledge, it's like, oh yeah, everyone knows you have to call verify transaction before you call make transaction. Otherwise, it's an issue, right? It might be a correctness problem, it might be a security issue. but you definitely have to do this. And so if I was going to use my favorite commercial tool, it's probably not going to support this. I'd have to pay for professional services. But with SemGrep, it's open source. I can start to think about this and define patterns myself. And so let's just look at what it looks like to write a custom check like this. So this code is a little bit snippeted because I used it to look at some different cases. But we have calls to verify transaction before make transaction. That's the good case. And then we have bad cases where someone's called make transaction and they've forgotten to verify it. You verified it late, so you made it before you verified it. And there's some other cases here. So like, let's say you have a call to verify on a different transaction because you made a new one, and then you're calling make on a different one. That's an easy mistake and something you'd probably miss in a code review if you're doing it manually. But if you can tell the compiler to help you out a little bit here, that's of course very easy to look for. And so you've seen a couple different SemGrep patterns, but let me just talk you through what's going on here. So we have pattern. This is what we're going to try to find. So any function, any method, any arguments, let's look for calls to make transaction. And then let's filter out all the cases where we have verify transaction as being called before make transaction. And I put 3 dots in between because we don't care about log statements or print functions, kind of whatever's going on. We just want to focus on the heart of the security problem. But we talked about here where we're verifying the wrong transaction, and that's because I've written the pattern a little bit too generic. So I've said any call to verify, as long as it happens before make, is fine. I actually want to enforce a variable, so let's do t for transaction. And then if I define that, now the SemGrep engine is going to go through and enforce that constraint that I just defined. So if I run that, we'll see now it matches because it's pretty obvious that that's a bug. Okay, so another thing I might want to look for is tell me whenever some developer adds a new route. Maybe I have privacy concerns I care about, GDPR, who knows what. I just want to build a function that looks at all route handlers. And so again, I'm going to just show an example. Instead of Python this time as a web framework, I'm going to use Gorilla. If you've written Go code, that might be familiar to you. But this is just a little snippet, but I have initialize route function, and then I have a bunch of different handlers being registered. So in this like fictional shopping cart app, you can see you have a couple different REST endpoints being defined. And so what I want to do, again, this will look familiar, but we're going to go through and do the same thing. So we'll just start abstracting things away. So app, router, and then what I'm going to do is just say, okay, that's the route. This is the handler. Maybe I don't care about that, but what I do care about is the verb. So cool. Now I have route and verb. I can actually put those as part of the message because it gets extracted into a variable. We have the verb be there. So if I run it now, we'll see. You can see now that the product and the verb get extracted. And of course, SemGrep has a JSON output, so I can now use that in other post-processing steps. So if I'm going to say, okay, every time a new pattern is abstracted, maybe send me a Slack message, that's pretty easy to do. What I also ended up doing was building out a D3 visualization where we went through and looked at all the hierarchy of all the routes, and then I color-coded it. It's not super important to read the details here. They're colored green, yellow, and red to say, like, okay, there's, authorization is maybe missing, or it might require like admin privileges to do something like add or delete a user. And so now it's very easy to see visually and kind of audit my code base and look and understand, did someone just forget to add a decorator where they said authentication required on an admin route, and that jumped out immediately. So that's an example of how you can use SemGrep to combine it with more powerful techniques and use it as a library. Next, we have a case where I have some insufficient RSA keys. And so oftentimes, if you're just copying code off Stack Overflow, you might have 1024-bit, but I happen to know that like we want better, more random numbers. Let's say 1024 is insecure. The recommendation now is 2048. So how would we do that? And what I want to talk about in this example, this loads. There we go. My internet blipped for a second. So we have calls to RSA generate key with 1024-bit, that we want to flag, and then 2048 is safe. And so it might be like you could certainly express that as hard-coded 1024 bits, but what if someone does 1028 bits? Kind of want to apply a little bit more logic. And so there's a built-in scripting engine in Semgrep where you can say pattern where Python, and then cast the bits variable gets extracted here into an integer, and then just make sure it's, if it's less than 2048, we want to fire on that. And so now I can start to mix and match both Semgrep patterns, Python patterns, and there's also a pattern regex, so I can go through and say, okay, find all variables where the value is password or something that's hard-coded. That's really powerful. So I started writing these patterns, and one of the first things we did was realize that people want to share and collaborate on these patterns. And of course, I'm not an expert in a lot of different subtle security bugs. And so we built a registry. If you go to semgrep.live/registry, it's just a nice front end over an open source Git repo, and people can contribute. And we write all of our rules here. And so if you want to talk to one of the foremost experts on JWT tokens, he's written blog posts and has written some rules, and that's part of the registry. And so now we can build this community of security professionals who are going to share learnings and comment and read the pattern and audit it and say, oh, but you missed this case. Here's a test case for it. And we have a whole testing framework. And so that's pretty powerful. Or if you're not quite sure what you want to start with, you can open up the registry, filter things down to just the languages you care about, and then just take those specific rules and run them on your code base. And really excited by the response so far. The author of Node.js Scan, Ajin, he was pretty excited about Semgrep, and his old engine had been powered with regexes. And so he thought, let me give this a try. And it took him about a month, but he ported all 70 rules over to using Semgrep and found a lot more issues in existing code bases because you have a little bit more precise analysis. So that was really cool. And actually someone from Vancouver, Damien, recently I was chatting with him. He's the author of the Go Perf book. He started writing not some security rules, but some performance rules. And so that was really cool. And he gave us some good feedback about some of the verbosity of the patterns. And so we're working on that. But getting started, it's a fairly new tool, but we're already really encouraged by the response from the community. So just to summarize, a couple different use cases. You can search your code for vulnerabilities, look for hotspots that you're going to audit, pull things out into different routes or codify your domain knowledge. And then you can also start to enforce things. So typically, the lifecycle we've seen works well is set this up on your code, notify just yourself. You're trying the pattern out. You're not quite sure you're ready to tell people about it or break a build, but you certainly want to look at it. And then once you get confidence that this rule is high quality, it's not going to be super noisy, people are going to get annoyed, you can flip a switch and start blocking builds and telling developers, hey, here's an alternative. If you haven't deprecated API, it's often easy to just write a Semgrep pattern and then run autofix and have it mutate the code base and go from version 1 to version 2, and you're not having to find replace with sed. You can actually do things at the semantic level using the tree structure. And then one other thing we've done is sort of going back and doing some historical analysis, looking back at old commits and looking for the burn down of projects. If you want to calculate metrics on how your code base is getting better or worse over time, you can kind of watch that by doing historical analysis with Semgrep. So that's pretty much it. Again, Semgrep's open source. It's really lightweight, works on many languages. You can go to the live editor and learn about it. You can do brew or pip install and play around locally. And if you want to get started, you can also just call it config equals R2C, and that will give a fairly fast set of rules. It's not everything we have, but it's just a good tuned rules that we think are pretty good. If you want to talk more, please go to r2c.dev, fill out our survey. I really appreciate any feedback you have. And if you want to just give us your email, that'd be great. We're going to probably put together a security learning group where people can talk once a month and say, hey, I'm newer to security. Let's go through and look for some vulnerabilities together. Let's understand what injection attacks are. So love your feedback there, but of course that's completely optional. And if you want a copy of the slides, I'll post them on semgrep.dev and our website. But if you want, they're right there on the bit.ly link as well.
Yeah, that'd be great. Drew. If you want to pass it on, we can also put it on OWASP Vancouver, put a link to the deck there as well.
Perfect.
Thanks very much. That was a really informative presentation. We've been looking at, like, just as a side note, like I noticed, we use Celis for an in-house product that we're using. We call it Eureka. We embed a bunch of other scanners, and recently noticed SemGrep was in there. So when you guys approached us to do the presentation, we've been actually trying to figure out, okay, great, it's in Celis, and we're bundling it within our product. How can we leverage it? So it was really nice to get this this presentation. A few questions there. It says, from Mark, does SemGrep's ability to abstract away the essay specifics of each language potentially become a crutch?
Maybe you can expand a little bit there. So one thing we try to do is we want to keep the pattern you're writing as close to the language you're writing. So we're not trying to write like a universal generic thing that, like, oh, this one pattern will find issues in every single language. I think we kind of, the design philosophy, say, like, learn the concepts once, and then if you're looking for Go code, you write Go code with a couple, dots to just abstract things away and make it generic. If you're writing Python code, the pattern's going to look different. It's going to look like what you're familiar with, in the code. So I'm not sure if I fully understand your question, but that's how we've kind of decided to think about it.
Mark, does that answer your question? Do you want to add anything to refine your question, or? Let's see, Mark says that was helpful. Thanks. Okay, cool. Next question was another one. So yes, the value is clear, but don't tools like this make trust a prerequisite, in that you have to trust the tool to parse the code for you? I know that Luke has been answering some of these questions, but I think, Luke, you said that you would like Drew to further elaborate. So I'll ask these questions again online.
Perfect. Yes. That's a good point. I mean, obviously, anytime you're searching the code, you have to trust your parser works. What we've been finding pretty good success with is a project called Tree Sitter. So that's open source by GitHub, and it's what powers like Atom, and there's semantic search, if you've seen, where you can like jump to definition on GitHub. And so it's kind of a common language, and there's parsers in 30 different languages, and it's a pretty easy way to write a grammar using like a JSON file. And so that's something that's been battle tested across millions of people on Atom. And we found just from our testing, like, parsers are 98.9% accurate. And of course, you can flag if there's a parse error. So like that also helps with trust too, like knowing, okay, like I want to run it in strict mode. Please alert if it can't parse a file. And so that's pretty helpful for just gaining confidence that what you're looking for, you actually expect to find. And then one thing we've done with all of our patterns is we've written test cases. So we'll always write kind of the unit tests. Let's run it on true positives, false positives, true negatives, make sure all those cases are there, make sure that all versions of the tool pass the test suite. And then we'll also run it on, we have a MapReduce platform that's kind of a internal thing we use to hunt for vulnerabilities, but I can go run it on 10,000 projects and then triage those and make sure that the pattern is finding things in real code. It's not like alerting on some edge case and I need to go back and refine my pattern. And so those things are just ways that we get confidence in our tool.
Excellent, excellent. Thank you, Drew. The next one is there a plan or existing feature wherein devs are educated as to why the code was flagged versus find or replace approach?
Yes, I'd be curious to get your feedback on like what you imagine to use this. What we've done is we've put in the YAML syntax this metadata field, and so you can put any keys and values there. And we always like put like references, it's like an array of links, OWASP categories, CWE categories. Maybe there's maybe you want a special key. Curious to get your feedback on. It's just like learn more or something that has a nice canonical write-up. But yes, I think like generally the spirit of your question is like, how do you help developers understand and be part of the dev training process? And yes, I think that's one of the things we want. Like if you imagine using some third-party scanner, it's not open source, you can't edit the rules. How do you kind of convey that? You have to have like, oh yeah, B107, it happens to be some cryptic error message. Here you can just like suggest a rule, fork the repo, change the message, and that works really well.
Excellent. I'm trying to see, there were a few other questions. Mark,
I said something about APIs. So we have a Python binding, and you can call it via Python code, and that's what the author for Node.js Scan did. that worked pretty well. But if you need a specific API, happy to chat more.
That sounds good. Jeevan had a question. He was wondering, does SemGrep fit into any IDEs for immediate feedback for developers, specifically interested about Visual VS Code?
Yes, actually I have lots of thoughts there, because one thing we're trying to do is integrate language server, LSP, language server protocol, to do some of the external file name resolution. And so we're big fans of VS Code. We use it a bunch ourselves, and we've not quite put a editor plugin we're quite ready to release yet, but we'll probably open source that later in the year. But it also has JSON output, and so I know one person at our company just hacked something together and got like the output in their editor. So we'll probably put some more energy into that later this year.
Excellent, thank you. Sophia, you had a question. Feel free to unmute yourself if you'd like to ask over audio.
Hi, a little bit more personal video. But yeah, so I had a question. I'm starting off in cybersecurity, and so my question was if tools such as SemGrep would be helpful to kind of getting more into learning how to become more of a researcher, or also as a software developer, or yeah, pretty much if this would be a good way to learn how to get into it a bit more as starting off.
Sure. So two questions there. I think like one way I would recommend is to start looking at some vulnerable code. And I know the OWASP group puts together like NodeGoat or some of these other intentionally vulnerable code bases, and you can start to see, can I find this? Could I write a SemGrep pattern to audit that code? Can I play with it? Can I run it and actually do the exploit? And there's really good documentation on projects like that. So that's probably a good starting point. Even outside of SemGrep, is to just play with things, try to break things. And yeah, as I mentioned, we also have like a monthly reading group where we don't talk about SemGrep. It's more of like, let's just go through and talk about security topics. And so if you're interested in sending me your email or something, can forward details on there.
Great, that sounds interesting. Thank you.
Of course.
And I believe there was one more question. It was something was mentioned about resolving variables in searches. How far back will it trace?
That's a great question. So right now, SemGrep will search inside a single file. And this is just one of the trade-offs we decided to make. So if you are going to support multiple different files, you have to handle different imports, and you have to understand how to build the project. If you're just looking at a single file, you can parallelize things. There are a lot of nice performance benefits you get. And I think actually in practice, what you usually end up wanting to look for are higher level patterns. So what I mean by that is, you could look across multiple different files and libraries and say, aha, right here is where the database call is being made. But in practice, what people are doing is they're calling a controller and they're saying, save user. And so you want to look for, that's the kind of good route. And then everywhere else, someone's making a raw SQL connection. You're like, what the heck? Like, please use the ORM that our rest of our app uses. And so that's why we found really good performance just looking across a single file. The performance is pretty good, and it also just kind of matches the mental model. If you have to look across 3 or 4 different files to see if it's a security bug, it's probably going to be hard to manually audit as well.
Thank you very much for that, Drew. Any other questions? Any other questions? Going once, going twice? Sold. All right, there are no more questions. Well, Drew, once again, thank you so much for this wonderful presentation. We'll give you a big round of applause.
Yeah. Thanks, guys. It was great to be here. And yeah, it's funny connection you mentioned with Salas. Brianna at Coinbase has been super nice, and we've had a lot of good back and forth about the best ways to integrate it into Salas, and kind of big fans of the work that they're doing there.
Excellent, excellent. All right, everybody. So our second speaker for the July edition of OWASP Vancouver is Baljeet Malhotra from Teej Labs. Baljeet will be speaking on the open API economy and managing security and compliance risks. He is the founder of Teej Lab and an award-winning researcher known for his work in open source and API data management. Before starting Teej Lab, he established the R&D unit of Black Duck Software in 2016. We all know who Black Duck is, and if we don't, you guys should find out. It's a very useful tool. Previously, he was research director at SAP and doing the computational scientist, was a computational scientist at the EOS Labs, 2009, and software engineer at Satyam Computers, 1999. He's received a PhD in computing science from the University of Alberta and was awarded an NSERC Canada Scholarship in 2005 and the Global Young Scientist from Singapore in 2011. He concurrently holds an adjunct professor positions at the University of British Columbia, University of Victoria, and University of Northern BC. With that said, I'd like to pass it on to you, Baljeet, and thank you.
Thank you, Farshad. I'm sorry for the glitch in the beginning. I couldn't dial in.
It's all, you're here with us now, and we're looking forward to the presentation.
Thank you. I'm sharing my screen now. Can you guys see my screen?
Yes, absolutely.
Okay, great. Thank you. Thank you, everyone. And really glad to be here. This is my first OWASP event attendance here in Vancouver. So really good to see the first presentation, very technical. My presentation is, I would say, less technical, but more on the overarching sides of API economy and what underlying security and compliance risks are there, and how we are attempting to solve some of those problems to help, companies and open source communities and developers alike. So let me give a quick introduction. How did I come to the journey of looking into APIs, which is the current focus of my startup, Tej Lab? I started my career as a software engineer, and then after a while, I realized that I needed to go to grad school to accumulate some knowledge to look into some of the interesting stuff that was happening in the cloud space, in the IoT area and whatnot. So I started doing my PhD around 1999, 2002 timeframe, and then moved on to do my postdoc at NUS. And there I joined SAP and be part of ESL Lab as well. And since then, I've been looking into open source management, security problems, largely from a data management, data science perspective. Security as much as is a security problem, but a lot of you understand it's also a data management problem. Mining unstructured data, looking into source code. Source code itself is a data as well. So when I was at SAP, we were looking into open source compliance across SAP products and services, and that's where I started really looking deep inside some of the security and compliance and licensing issues we were having. At a point, I was at a level where I needed to do more than what I could do within an enterprise, and I left SAP to start the R&D division of Black Duck. In many ways, it was my startup, but funded and branded by Black Duck. So my team was essentially responsible for applying data science, data mining, and other machine learning technologies to mine large volumes of data, extract knowledge, either security related issues or compliance related data to bring visibility for our enterprise customers. Since then, I've been looking into API problems as well, but it was not until when Black Duck was acquired by Synopsys, I left, and that was my exit to start Tej Lab in 2018. And since then, I've been looking into API, compliance, API security related problems. And this picture essentially depicts the ecosystem we are part of today. This could be a view of an organization. This could also be a global view where you have partners spanning across different industries, different businesses. You could be integrating products and services from different organizations with your products and services, and that's where APIs are playing a major role. APIs are not new, as many of you already know. The concepts have been existing since 70s. It's just that a lot of these APIs are becoming, because of the integrations, because of the movement of software and data into the cloud, lot of these APIs are becoming web APIs, essentially, interfaces or programming concepts being exposed through internet for various business and technical functionalities. That's where a lot of industries have revolutionized their business processes, starting with banking industry, fintech is of course huge in there. A lot of logistic companies, pretty much every company on the planet is looking into these API ecosystems. Either you are building your own APIs or you are consuming APIs built by others. Let me give you a brief history of how and when we, as a company at Teej Lab, started to get involved into this space. At Black Duck, of course, everybody knows Black Duck was a market leader in open source risk management, and we found that as the open source libraries were increasing and more libraries were becoming available through platforms like GitHub or other publicly available sources, we found that even enterprise applications using those libraries, up to 67 or 70%. These numbers are a bit old now by this time, but pretty much every enterprise application is today using open source. This is the research done by us. Likewise, we started to see a trend for APIs as well, where we pretty much actually see a war happening between these different large enterprises, where they are building more and more APIs and providing different open source tools which have these integrations for various business and technical functionalities. This particular graph on the left-hand side depicts a scenario from a research we did in which we analyzed roughly around 2 million open source projects that were publicly available, including GitHub. And each data point on this graph represents what kind of API integrations we were seeing from these 5 major companies: Google, Facebook, Microsoft, Amazon, and Salesforce. As you know, from the day one, Amazon and companies like eBay, they have championed this API-driven economy. And what is interesting is when we try to analyze this graph with respect to open source usage that we see over the last decade or so, the growth of API usage is proportionally quite large compared to the open source usage. In many ways, you can say that APIs are the modern days open source. Pretty much every company is providing these integrations. Either they are web solutions, pretty much they are mostly available in SaaS kind of solutions, but you will see a lot of API integrations in mobile applications, social media, and whatnot. Now, I just want to make sure that we cover the basic aspects of today's talk, which is about what are the underlying compliance and security issues we see with the growth of these API usage across different products, across different industries. As I mentioned, we looked into open source projects, we looked into proprietary code bases and other available sources, and we find that there are 4 basic sources of API growth in any enterprise. Developers using open source, you may use an open source library for one reason, but perhaps those open source libraries have certain APIs that you are not aware of. Many of these could be open APIs or APIs that you may not be using, but they are there, hence posing certain security and compliance risks. Similarly, there are third-party integrations. You might be white labeling solutions, integrating with third-party solutions, or outsourcing your development to third parties where these API integrations may come in. Or the other major source we found is the acquisitions. companies are buying companies, and when they acquire assets, you see a lot of these API integrations coming into the picture. And we have seen in one particular case where we had bought a company, and believe it or not, but within one single product, there were 5,000 plus different API integrations. Now that's a different question. How did we discover those 5,000 different API integrations? Imagine the situation needed to be found out, who the vendors are, do we have commercial agreements in place, what these APIs do, what data goes in, what data comes out, all those kind of issues. And so there are a lot of compliance challenges, security challenges, reliability issues, because API may be secure, API may be compliant, but is it reliable? Could it be a API that is built by a developer sitting in a garage? What if he goes out of business and if his product starts to depend on that API, which is very cool API, but there is no business backing to that supporting API. So all those issues come up when you start to use APIs that you did not build, and that's the future we are heading into, just like with open source. A few weeks ago, rather a few days ago, Farshad was our guest speaker. He spoke about in one of our events about API security, and I asked him this question: Farshad, what do we do with respect to the APIs that we did not build? Of course, a lot of this OWASP, top 10 OWASP API security issues are you can do a very deep testing. If you build those APIs, you have access to the source code, and you can do a good job in mitigating any risk if you have built this API. But what do you do in the case if you have not access to those APIs because you simply didn't build these APIs? So what kind of benchmarking you can perform on those APIs? And that is what we are going to address for the rest of the session. Now, one very critical issue for enterprises today, specifically for a role like CISO or CTO or a CIO level, they do not have visibility into all the APIs across their different products and services. And as I mentioned, if we had 10 APIs, 20 APIs, one product, two products, it is still manageable through manual techniques. You can ask developers to proactively declare, consolidate those APIs in a marketplace, and manage your lifecycle of your APIs in a reasonably efficient manner. But the problem is we are dealing with hundreds and perhaps thousands of APIs, and those thousands of APIs are integrated across hundreds of different applications deployed in different cloud environments. So this is a really a big mess that we see in lot of the situations where not having the visibility brings a lot of risk to the organization. Now, some of these challenges I've highlighted in a very broad categories of invisibility, usability, scalability. Now, let me go into those just very briefly. Invisibility is when you actually do not even know which APIs are there in your organization. And remember, recall my previous slide when I mentioned that APIs are not something that only you are building. APIs could come from open source usage, APIs may come from third-party integrations, APIs may come from the companies you acquired. Usability. So you may have situations where you're building APIs for your internal usage. You might be building APIs for external usage. You might be building APIs that are behind firewall but have a proper access control mechanisms, but then you might be building APIs that are publicly available through other less stringent techniques. Likewise, scalability is a huge issue. For example, you may have products that need to call APIs maybe hundreds and thousands of times per minute. You may have APIs that you may just call once or twice. So how do you deal with all these ranges of issues? How do you manage your security testing? How do you manage your compliance aspect? How do you manage the life cycle of those APIs? I was listening to the first presentations. You may have, just like you are deprecating certain libraries, you might be deprecating your APIs, the new versions might be coming in, and if your products are depending on those, how do you even detect those issues? How do you perform these testing OWASP top 10 if these are the APIs you did not build? So all kinds of issues are there. Now, I just want to give a quick pause here and maybe check back with you, Farshad. Are there any immediate questions at this stage I can answer before I go further?
Thank you so much. I'm looking at the Zoom and there are no questions at this point, but I'd like to just put it out there back to the audience. If does anyone have any questions, you can feel free to mute yourself, or you can post your question on the chat and I'll read it out for everybody.
Okay, so Farshad, please feel free to stop me if there are any questions that is important for the understanding for the rest of the presentation. But in the meantime, I will just continue.
That sounds great. Thank you.
So at Teach Lab, we are tracking this growth of APIs at a global scale. Today, we have world's largest repository of APIs that are vetted from security and compliance perspectives. There are repositories, there are other kinds of repositories that are there, but they might be just providing just the endpoint information, the vendor information, the authentication documentation, how to integrate those, but nothing like us, where we have actually vetted these APIs on a global scale, looking at different industries, different segments, different businesses, different vendors, different categories of APIs, and not just from a security perspective, but also compliance perspective. One of the large compliance issues we see around APIs is the terms of services. So many APIs are being built with a public interface where you can start to consume them, but there is a business policies around those APIs. If you go above a certain call, you must have a commercial agreement in place, and the terms of services may change. You have to be compliant with those terms of services. And there are other kinds of issues as well, which evolves around legal compliance. Now, in order for us to actually assess the state of the art, how bad the situation is when it comes to these publicly available APIs. As I mentioned, we are tracking 20 different industries and different APIs, logistic APIs or personal APIs or Facebook APIs or LinkedIn APIs, all kinds of different APIs we are tracking to assess their security posture, to assess their legal posture, to see what the legal risks are, and other aspects of the issues around using those APIs. Assessing every single API was certainly a possibility, but that would have taken a longer time for us to assess and provide a guidance to the community. So we took a fairly large sample of APIs that we actually went ahead and did a more deep dive testing for those APIs than we could see just by looking at their documentations or other aspects of information that was available. So this was the sample size we took. Many of these APIs, the thousands of APIs I mentioned in my previous slide, you can go to the API Discovery platform, which is a publicly accessible platform for the community. There is a freemium version we have made available where you can see the integrations of these APIs, you can run them. But these were the vendors and the APIs and endpoints we took as a sample data set where we wanted to do even deep dive testing on these APIs. So roughly we took around 400, little over than 450 vendors from different industries. We took roughly around 1,200 APIs from these different vendors. And as you know, each API may have different endpoints, different methods that basically provide different functionalities. And we took roughly around 2,000 different endpoints belonging to these different vendors and APIs. Here is the first result. If you remember the top 10 OWASP API security issues, we found that lot of these APIs did not even have any access control mechanisms. Pretty much free, you just call them. We found that out of those numbers I mentioned on the previous slide, pretty much 42% of the vendors were providing certain APIs did not have any access control mechanism. No basic auth, no API key, let alone OAuth or other complicated mechanisms of access control. Out of 32% of those APIs, they had those from the API sample we took, 32% didn't have the access control mechanisms. And many of those endpoints, some of them they had, but 30% of those did not have any access control mechanism. We also looked into if they had any access control mechanisms, what was the actual security posture of access control of those APIs. In particular, I don't need to tell this community that you guys are quite advanced when it comes to the security topic, but this is a very simple case of not using a standard way of authentication. So in this particular case, we found that the API keys were being passed as part of the URL parameter. In some cases, they were just a path segment. So again, as you know, browsers can cache those API keys, and hence this is not considered as a secure way of using those APIs. Again, roughly 29% of the vendors we found were doing that. 34% of APIs provided by them were doing that, and 30% of those endpoints belonging to those APIs were actually using this unsecured access control mechanism. Now, we also wanted to see, even if these APIs are there, if they have good access control mechanisms in place, if they are providing a secure way of exchanging API keys, and also authentications which are a bit more secure, like OAuth or JWT or other kinds of access control mechanisms. We wanted to see what other problems exist with those APIs. So that will come on the next slide. But this particular slide sums up, if we put together no access control at all or unsecured access control at all, 72% of the vendors fell into this category. Only 28% of the vendors, we would say, they were providing a more secure way of API access. Likewise, 60% of the endpoints and 67% of the APIs are actually not providing any access control mechanisms, or access control mechanisms that are not necessarily very secure. Now, this is what I was talking about. I think it's OWASP security problem number 3, that APIs may expose sensitive data, either as part of header response, or either they are giving too much information in their response, or in their header messages they are containing information that could actually jeopardize or could lead to a more sophisticated attack. In this particular investigation, we found that 39% of the vendors were revealing their underlying API server information. Nginx, Apache Tomcat, or other kinds of API gateway servers that might be routing the API traffic were exposing this information. Now, this is important. Although you may be still caught at the authorization level if you compromise the authentication, but the point is, if the attack is launched and this API server goes down, and you depend on this API, which is publicly available, then what is the impact on your business continuity? So just don't think that you only need to secure your own APIs that you build, but also think about the APIs that you are depending on. And hence, this use case is important to know whether these APIs are actually revealing sensitive information that hackers can exploit to launch more sophisticated attacks. So in this particular case, we're looking at server information revealed by these APIs. So let me give you a quick demo of what I'm talking about. So if I go to some of the APIs explorations we did, then providing the information where you can actually see what API server is actually serving this particular API could actually be detrimental for this using this API. So here in this case, we detected that this particular API is using nginx server version 1.19. Not only that, but we were able to actually relate it to the publicly available vulnerabilities that are available through NVD database or other forms of other places where we could map these vulnerabilities to the software versions we detect. Now here I'm showing you that this particular nginx version is detected, and the vulnerability is pretty old, but these vendors are basically using a unsecured server. Now, oftentimes it is possible that this information itself is wrong. So this is quite possible, but in many cases, in this particular case, this is not a vendor that is hosting its own API. They are using a vendor which is basically providing the services. So we would imagine that this information is perhaps not coming directly from the API builders, but actually the service provider. And if you remember some of the vulnerabilities that were caught, for example, that a credit agency that was caught with the Apache Struts vulnerability exposure a few years ago. I mean, these are the kinds of problem where we see that the vulnerability is published for a long time, but vendors or organizations do not really move forward proactively to patch their servers and hence expose themselves to attacks. Likewise, we have found even cases where actually we could see that the vulnerabilities are published a long time ago, but we see, thank you, Jeevan is saying Equifax. So yeah, I couldn't remember the name of the company, but Jeevan, you're right. Thank you for reminding that. So here in this case, we are showing you that this particular particular API is hosted on a server which is using again Apache Ubuntu version 4.3 or maybe this is wrong information, but revealing this kind of information could actually lead to more sophisticated attacks. Now coming back to this graph again, not only we found that there were APIs that were revealing this sensitive information, but we also found cases where actually we found the actual vulnerabilities that we could map to these servers that were leaking their information. So in this case, I'm showing you a graph in which we are saying that out of 100 cases that were revealing their server information, actually we found that 31% of them were actually affected by publicly known vulnerabilities. Now there is another issue around API usage, which is data governance aspect of that. And one of the risks that companies expose themselves when it comes to the usage of APIs is, although the company might be based in a region where you prefer the vendor to be in, for example, a Canadian company may have an obligation of not sending their data outside Canada, just for example's sake. And they might assume that the company which is in Canada might be doing the same thing, but not necessarily, as you can imagine. So data governance is a huge issue. And we often found cases where, as I mentioned, we are tracking the actual geolocations of these servers across different geographies, across different vendors at the API level, where we can see where these services are hosted. So here I'm showing you a quick snapshot of the global view of the APIs we tracked on the sample data that I showed, where you can see, this might be an API which is in particular, for example, I can show you going back to this. So you might think that this particular API is this particular company, which if you go to their website is a Canadian company or a US company, but actually if you go look into their visualization as we capture, they might be hosting their services somewhere in Bangladesh or in Sri Lanka. We found cases, as far as down south in Australia. We found a couple of cases in Sri Lanka, in the Asian region, very few in China, but we found some cases in India. We found one case in Bangladesh as well, but majority of those servers were hosted in either in Europe or in East Coast or the West Coast, some in Central Canada or the US, but majority of them, as you can see from this graph, they are mostly hosted on the East Coast or West Coast. Now, here is the interesting point. For a GDPR compliance, you may assume that you are using a speech recognition API or a security testing API or other kinds of API, but surprisingly, your data is shipping back and forth to a Chinese server. Imagine the impact on your business process. Imagine the impact from your audit perspective. So knowing all those issues in advance is actually very key to your success as a business, because you do not want to, in a situation where you start to depend on these API integrations and suddenly you find yourself in a situation where you need to duplicate these APIs, or simply because vendor couldn't move to a location on time, and hence your business continuity is affected. Now, let me sum this up, and I want to keep some time for Q&A. But let me do a quick check with Farshad. Farshad, how we are doing on time? Are we good on time?
Yes, yeah, we have time, absolutely. Your presentation started at 7:10, so we've got another 20 or so minutes.
Okay, so I'll try to wrap this up in 10 minutes, and I want to keep additional 10 minutes for Q&A.
Absolutely.
So now, I've talked about a lot of issues. I've talked about the security aspects of APIs, the compliance aspects of API. If you happen to use this platform, you will see a lot of interesting data points where you can start to see, even if you are using those APIs, what could be the underlying issues that you're facing. Especially, we see a lot of startups that are that depend on these APIs for faster product delivery, go to the market faster. The API integrations are very, very important to them. But sooner or later, as part of the due diligence, they need to go through technical due diligence, legal due diligence, and other aspects before they are either funded or acquired. So a lot of startups, they are not aware of these issues, and not just startups, but also very matured companies. When they are transacted, we see all those issues at once. As I mentioned in one example, we purchased a company which was relatively small but needed to be part of a large ecosystem. So one single product needed to be scaled to a very large number of API calls. So we needed to figure out, who the vendor is, how many APIs do these APIs are free usage basis, or we need to have a commercial agreement in place. We did not even know what the terms of services were, let alone having the commercial agreements in place. Now let me switch your gear a little bit. I did talk about on my slide about the open source usage. One of the problems we are trying to solve and help the open source community, and hence the developers that are the soul of this open source movement, who are contributing their blood and sweat to the open source community. We wanted to understand what kind of issues are there. We picked up, for example, Kubernetes. We picked up Apache softwares. We picked up other SaaS solutions that are publicly available as open source solutions. And what we wanted to find out was, are there any API integrations that could pose any security and legal issues? So let me quickly give you a quick snapshot of some of those results. So if I go to some of our dashboards, which are basically these are already processed results. Let me take you to one of the open source projects we scanned. So you will see GitHub integrations. Of course, if it is a development tool, if it is a Jenkins kind of or other kinds of cloud orchestrating software, then of course you will see a lot of DevOps related APIs. But surprisingly, we found cases even when we scanned, for example, Kubernetes. We found YouTube integrations. We found payment integrations. Now we do not necessarily know what was the reason behind those integrations, but I could imagine that every project is trying to provide integrations that could make that community independent. All the integrations are there so that that project can be successfully integrated with different business or technical functionality. Let me give you a more concrete example. Here is a very popular peer-to-peer chatting application that is open source project, which has Gmail API integrations, Slack integrations, GitHub integrations, and other kinds of integrations. We discover what are the underlying licenses. We discover what are the security issues. We can discover are they using API keys or other kinds of authentication mechanisms in a secure and compliant way. So this was one of the reasons we made it freemium was we wanted to help the open source community, because when they're integrating these plugins or these projects into their products, they may or may not be aware of these API integrations, and hence this could bring more visibility to them, and hence could create value for them. So I will stop here and try to summarize what I tried to cover. So why APIs need to be looked into from a risk management perspective? Why security and compliance is important for APIs? So this slide pretty much sums up what I wanted to describe and I have covered in this session. Is you need to provide better coverage, just like static scan solutions for software or pen testing. You need similar kinds of solutions for APIs as well, especially when the APIs are becoming open APIs, when the APIs are coming out from firewall and publicly available on the internet for various integration purposes. And foremost, the important point is the discovery. If you do not even know what APIs are there in your environment, how do you even assess them? So discovery is a huge problem. If you are not able to discover, you cannot gain the coverage. But if you have tools, right kinds of tools, this problem can be addressed. Because you are able to discover APIs, you can cover your attack surface, you can protect your applications, and you can do things that will make you more secure and compliant. Also, from just a cost-effective perspective, imagine. So we have plugins. You can have Eclipse plugin. You can have other IDE plugins where the moment you download a library, the tool can tell you whether there is a API integration in the library you just downloaded. So this saves you cost, the development cost, but also the legal and the security cost that can hit you hard down the road. You do not want to be in a situation because of these unsecured APIs you are hacked, and hence you are looking at fines, penalties, and other audit-related issues. Even regardless of whether you are hacked or not, even for compliance perspective, sometimes you want to do these things for PCI compliance, SOC 2 compliance, HIPAA, GDPR compliance, and all kinds of compliance obligations you have in your organization. So, covering your, attack surface from coming through these APIs, is important from your risk management perspective. And last but not the least, when you have these APIs covered, either from security, reliability, or compliance perspective, you are building trust. And APIs are such a such a important topic right now with the digital transformation taking in place. And the difficulty is it's not a security only problem. It's not only a development problem, but APIs are being treated today as products. You know, organizations have their product strategy built upon these API integrations. Each API is like a product to them. There is a monetization strategy, there is a digitization strategy, and there are other business components attached to that. And hence, there are licensing teams, there are legal teams associated with API management. So you got to build trust across these different teams who are responsible for managing the legal aspect, all the way from developer doing the OWASP testing on the APIs, or the security expert testing the OWASP benchmarking on those APIs, all the way to the business leader approving the usage of those APIs from a cost perspective. So you got to build this trust end to end. Once you build those trust, you know, that is transferred, of course, to your customers and partners, which start to depend on you. And I was reading this recent article by Akamai Technologies that they published recently, and they somehow quantified that 80% and above internet traffic is through APIs now. Now, this also means, in theory, the attack surface, 80% of the attack surface is through APIs now. And hence, this is a very, very important problem to address moving forward. As I promised, I want to leave 10 minutes or so for Q&A, but this is my contact information. Happy to chat right now, or please feel free to reach out to us. This is my personal email as well. There is a generic email address as well, which goes to a team. And also we have linked to our platform. If you, as I mentioned, there are freemium tools available for you to try and use them for various purposes that you see fit. Farshad, I will stop here and give a pause to see if there are any questions that I can answer.
Sounds good. Thank you so much, Baljeet. It's been a great presentation. Are there any questions? I'm looking at the chat and I don't see questions posted on the chat. Just to everybody, feel free to unmute yourself if you want to ask the question directly, or post it on the chat for us. This is, this is a topic, as you already know, Baljeet, that's pretty close to heart for me. It's one of my favorite topics is API security. And it's one that's often overlooked. People aren't really doing the right thing in a lot of instances. So it's great to, have these discussions and have these conversations and bring some of these to light and for people to know what kinds of things they need to do. I don't see any questions. Okay. I don't have any other questions myself. Baljeet, are there any takeaways you want to leave the audience with? Are there a couple of things that are like, hey, when you leave this, these are the couple of things you should pay attention to or go read up on, or a couple of takeaways?
Yeah, one of the takeaways I would definitely recommend is when you integrate open source libraries, look for API integration. Mm-hmm. If you are familiar with those APIs, that's good. If not, then pay a closer attention. And also, a lot of APIs are becoming available. Just because these APIs are by Google or Facebook, do not trust that they are fully secured. We have found cases in which a lot of APIs by trusted vendors are also compromised. And there is a security blog that anybody can go, security.io. They can see a lot of API related issues on those platforms. Especially in Android recently, we saw a lot of API related problems. Likewise for Facebook APIs, for very even some Google APIs, we found some cases. I mean, API is such an important part of your software development lifecycle now that this is just very difficult to ignore anymore.
Absolutely, absolutely. Yeah, thank you for that. Well, thanks again. We really appreciate you doing this session for us, and I hope it was useful for everybody. I'd like to also thank Bugcrowd for sponsoring and providing the gift certificate for the AppSec Trivia. I'd like to thank all of the OWASP Vancouver Volunteer Board, Jivan, Amiran, Artie, Betsy, Eric, Hari, and Lilitha for all their time and efforts for helping making these things happen. We have some exciting events coming up. August 20th is our next one. It'll probably be a special outdoor format where we'll send the details. You can find out more about our events by Googling OWASP Vancouver. We have a page within the OWASP website. Also, we have a Slack channel, as I mentioned earlier. If you go to fourthplanet.ca/Slack, once again, that's fourthplanet.ca/Slack. You can register there to join the conversation between these meetups. There's always a party going on, so if you're not there, you're missing out. There's various other channels within the Fourth Planet Slack team as well, mostly cybersecurity related and some general channels. With that said, thank you very much, everybody.
There was that one,
yes,
right? Arthi was mentioning that there is IT World Conference.
yes,
It's celebrating Canadian women in cybersecurity. That's happening on July 23rd. So I'm going to dump the link in the chat. So if you do want to attend that, it's available there.
Thank you so much. And yeah, I thank you so much for sharing that, Jeevan. Also, Karen had shared a link for a survey about Drew's presentation, and Jeevan, you shared a survey about this session as well. So if people could take a couple of minutes, we would really appreciate your feedback and how everybody can do better in what they're doing. Feedback is always very helpful and appreciated. Other than that, yeah, let's have a great evening and hope to see you at the next one. If anybody is interested in speaking at one of these sessions, email one of us, Jeevan and I. Contact information or ways to contact us should be on the OWASP Vancouver page. With that said, thank you very much and have a great evening. Thanks again, Baljeet.
Thank you, Farshad.
Thanks, everyone.
Bye, everyone.